Welcome to the Psychology and Physical Training channel, Introduction to Statistical Errors. Ever wondered why sometimes researchers get their predictions wrong even with a well-executed study? Well, let's embark on a journey to unravel the mystery of statistical errors. Now, when we say errors, we're not talking about blunders or slip-ups. Rather, these are inherent risks that come with the territory of research. Imagine you're navigating through a dense forest. Even with the best compass and map, there's always a chance you might stray from the path. And that's exactly what statistical errors are. They're the deviations, the unexpected turns in your research journey. Now, these errors are not all the same. They come in two main types, Type 1 and Type 2 errors. Each has its own characteristics, causes, and implications. They're like two sides of the same coin, both essential to understanding the whole picture. Understanding these errors is key to evaluating the quality of a research study. So, let's dive in and explore these intriguing concepts further. Understanding Type 1 errors. So what exactly is a Type I error? Well, imagine you're a detective on a case. You've got a suspect, and all your evidence points to them. You're sure they're guilty, so you reject their claim of innocence, the idea that they're null, or nothing to do with the crime. But then, plot twist, they were telling the truth. You've just made a Type 1 error. In statistical terms, a Type Y error is when we incorrectly reject a true null hypothesis. Picture the null hypothesis as the suspect's claim of innocence. When we reject this claim, even though it's true, we're making a Type 1 error. We're essentially finding guilt where there is none. Now let's bring this concept to the world of research. For instance, suppose a pharmaceutical company is testing a new drug. The null hypothesis might be that the drug has no effect. If the company concludes that the drug does have an effect when it actually doesn't, they've committed a Type 1 error. They've found an effect that isn't really there. The implications of a Type Y error can be significant. In our pharmaceutical example, the company might invest millions into producing and marketing a drug that actually doesn't work. Or worse, it could lead to patients not receiving the effective treatment they need. But it's not just in drug research where these errors can have serious consequences. In any field, from education to economics, Type 1 errors can lead to incorrect conclusions, misguided policies, and wasted resources. They can cause researchers to chase ghosts, pursuing non-existent effects or relationships. So how do we avoid these errors? Well, that's a complex question and a topic for another scene. But for now, remember, a Type 1 error is essentially a false positive. It's seeing something that isn't there, finding guilt where there's innocence, or detecting an effect where there's none. In essence, a Type 1 error is finding something that isn't really there. Exploring Type 2 errors. If that's a Type 1 error, then what is a Type 2 error? Well, while a Type Y error is about seeing something that isn't there, a Type 2 error, on the other hand, is about missing something that is indeed there. At its core, a Type 2 error is the failure to reject a false null hypothesis. In plain English, it's like not hearing the fire alarm when there actually is a fire. The null hypothesis, which is the assumption that there is no significant difference or effect, is false, but we fail to detect this. We're missing the evidence that should lead us to challenge the status quo. Let's illustrate this with a scenario. Imagine you're a researcher studying a new medicine that you believe could significantly reduce symptoms of a disease. You conduct a clinical trial, and your null hypothesis is that the new medicine has no effect. After the trial, your results don't show a significant reduction in symptoms. So you fail to reject the null hypothesis, concluding that the medicine doesn't work. But what if the medicine actually does work, and you've simply missed the effect due to some limitations in your study? That, my friends, is a Type 2 error. Now, the implications of a Type 2 error can be serious. In our example, if the new medicine actually does work, failing to recognize its effectiveness could prevent patients from receiving a potentially beneficial treatment. It could stall the progress of research and development, and even have life-altering consequences for individuals relying on these medical advancements. It's important to note that Type 2 errors are not necessarily a result of poor research. They can occur due to a variety of factors, such as sample size, measurement errors, or even random chance. But by understanding what a type 2 error is and being aware of the potential consequences, researchers can take steps to minimize these errors and enhance the reliability of their findings. So, remember, a type 2 error is missing something that is indeed there. It's failing to hear the fire alarm when there's actually a fire. It's a reminder for us to always question our assumptions and to keep our eyes and ears open to the evidence. Contrast between type 1 and type 2 errors. Type Y and type 2 errors seem quite different, don't they? Indeed, they are. Type I errors, also known as false positives, occur when we reject a true null hypothesis. It's like convicting an innocent person. You've seen evidence that's led you to the wrong conclusion. On the other hand, type 2 errors, or false negatives, happen when we fail to reject a false null hypothesis. It's akin to setting a guilty person free. You've missed the evidence that would have led you to the right conclusion. Now, let's tie this into statistical power and significance level. The statistical power of a test is the probability that it correctly rejects a false null hypothesis, essentially helping us avoid type 2 errors. It's like the detective's knack for finding the guilty party. On the flip side, the significance level is the probability that we reject a true null hypothesis, which is the risk of committing a type 1 error. It's the judge's tendency to convict regardless of innocence. You see, researchers must strike a delicate balance here. If they set a low significance level to minimize type 1 errors, they risk increasing type 2 errors as the test becomes less powerful. Conversely, if they increase the power of the test to reduce type 2 errors, they may end up with more type Y errors due to a higher significance level. It's a bit of a statistical seesaw. There's no one-size-fits-all solution. The balance depends on the specific research context. In some cases, a type 1 error might be more costly, like in a clinical trial where a new drug might harm patients. In other cases, a type 2 error could be more detrimental, such as in quality control where a faulty product might slip through. So, while both errors are undesirable, they represent different types of risk in research. Understanding these risks and how to balance them is key to conducting robust and reliable research. It's all part of the challenging yet rewarding world of research methodology. While both errors are undesirable, they represent different types of risk in research. Mitigating type 1 and type 2 errors. Is there a way to avoid these errors altogether? Well, not entirely, but we can certainly minimize them. Consider type 1 and type 2 errors like pesky flies at a picnic. You might not be able to eliminate them completely, but with the right strategies, you can certainly keep them at bay. First off, careful study design is crucial. This includes ensuring that your sample size is large enough and that your measurement methods are reliable. The better your study design, the less room there is for errors to creep in. Next, using appropriate statistical tests is paramount. Each test has its own strengths and weaknesses, and knowing which one to use in a given situation can greatly reduce the likelihood of committing these errors. Remember, while you can't completely avoid type 1 and type 2 errors, you can certainly reduce their likelihood. By understanding and addressing these errors, researchers can improve the reliability of their results. Recap and conclusion. So let's take a step back and summarize what we've uncovered about type 1 and type 2 errors. These statistical missteps, while seemingly complicated, are integral to the integrity of research. We dove into type Y errors, false positives that occur when we incorrectly reject a true null hypothesis. Then, we ventured into the realm of type 2 errors, false negatives that transpire when we wrongly accept a false null hypothesis. We distinguish between these two errors, highlighting the inverse relationship between them. As the probability of making one type of error decreases, the probability of making the other increases. That's the balancing act of research. We also touched on strategies to mitigate these errors, like adjusting the significance level or increasing the sample size. But remember, the importance lies not in eradicating these errors, but in understanding and managing them. Because at the end of the day, this knowledge enhances the quality of scientific research. Remember, the goal isn't to eliminate these errors, but to understand and manage them, improving the quality of scientific research. And if you like this video, do not forget to subscribe and follow to the Psychology and Physical Training channel for more videos. Thanks for watching.